Welcome back to Math 107 College Algebra. In this video, we're going to take a look at more of the conceptual idea of an inverse function. And then in the next lesson, we're going to look more at what we want to do mathematically. So first off, the inverse of a function, we're simply going to switch the variables that define the relation. So for example, if I give you the relation y equals x squared minus 5x, and I want to convert this and find the inverse, all that I need to do is replace all the x's with y's and all the y's with x's, and then everything else is going to stay the same. So the inverse of y equals x squared minus 5x is x equals y squared minus 5y. But the question we want to ask ourselves frequently in mathematics is, when is this inverse a function itself? And in order to do that, now clearly in order for it to be a function, every x has to correspond to exactly one y, which means in the original function every y has, or at least every y that is in the range of the function has to correspond to exactly 1x. So what this is called is a 1-to-1 function. And by definition, this means that f of a equals f of b if and only if a equals b. Now sometimes they'll only show that one way, that f of a equals f of b implies that a equals b, because if a equals b, that's obvious. So we can use this to determine whether or not a function is 1-to-1. So I might give you a function like f of x is equal to 2x minus 3. And I want to determine that it's 1-to-1. So we're going to let just a generic a and b. So f of a, and actually we don't want a question mark there. We know for sure f of a equals f of b. So now we'll go ahead and plug in our definition. So 2a minus 3 equals 2b minus 3. And then we can add 3 to both sides. We get 2a equals 2b. And now divide both sides by 2. A equals b. So we've proven that if f of a equals f of b, in this case, a has to equal b. So therefore, it is a 1-to-1 function. Now, I show you this in the interest of being formal. But in class, we're going to take a look at some different ways that we can look at this, so that we don't have to prove this every time, because this is something that's rarely necessary outside of pure applied or pure theoretical mathematics. So that will conclude this video. In the next set of videos, we're going to take a look at some ways we can find the inverse of functions.